So in this video, we are talking about piecewise functions. Now, a piecewise function is a function made up of smaller functions for different intervals along the domain. So a nice and easy way to think about this is think of it as just this bigger function made up of these mini functions that can change as we go along our domain. So for different inputs of x. So just a rough kind of example of this, that could look something like a function where at a certain point over here, it's a quadratic, and then it becomes a linear function after that. We have basically two smaller functions. We have a quadratic, and we have something that is linear as well. So this can take on a whole bunch of different forms. We just have these sort of smaller functions, 1, 2, that make up a larger function, which we call the piecewise function. Now, the way we actually notate these is very similar actually to how we spoke about our absolute value function in previous videos. Now, an example of this could look something like this. Now, please note that what I'm writing here isn't the function that's here. This is just giving you a different example. Now we use this kind of curly bracket here. So a piecewise function, one could be that it's the line x plus 1 for x is greater than or equal to 0. Or it could be, and then it becomes x minus 3 when x is less than 0. So we have our two individual functions. Now, this will represent this particular line on the domain of x being greater than 0. So in the positive x-axis, and when we get to the negative x-axis, it becomes x minus 3. So the things we've been doing with our absolute value function has kind of actually been preparing us to tackle these piecewise functions. Now, one more thing we're going to quickly talk about before ending this video is this idea of continuity. Now, a continuous function is one if it has no breaks, jumps, or holes in it. Now, what that basically means is our piecewise functions can look a whole bunch of different ways. We can have the initial one that we had drawn before where it's, say, like a quadratic, then a line, and maybe it goes like this again. You can see how I drew this. I went over it without taking my pen off the paper, right? I could draw a continual tracing over this. So it basically has no breaks. So everything joins up perfectly. If something's not continuous, it might look something like this. I draw up a quick pair of axes. It could look something like this, where maybe it gets to here. And then all of a sudden, my function jumps up to here. So suddenly I have basically a function where it looks like it behaves like a quadratic roughly from here to here. And then suddenly there's a big break over here. It jumps up to become this linear function. It's still a piecewise function because it's these different mini functions along our domain, along our different inputs of x, but suddenly it has a jump. So it stops here, then it jumps up to the top. What it means by holes is, say we have something like this. Let's say we had a line, but at a particular point, say it gets to here, and then there's something about our line that causes it to have a discontinuity here. It has a hole. So there's no output for this particular input of x. And we're going to look at a few examples of this later on. But when we consider these, our one that we drew up over here, this is continuous because we could trace over it without taking our pen off the paper. These two are not continuous. And if you even imagine trying to draw this, the first one, we had to take our pen off the paper because there's nothing joining these 2 points. So we take our pen off the paper, we start over here. With this particular one, you might argue, well, we can draw a line all the way through here, but you've got to take your pen off the paper and draw this open circle. And This hole is just basically like a break in our function. There's no value, there's no output here given for this particular input. So the ones on the right are our not continuous function. The one on the left is continuous. These initial definitions are just going to help us when we end up tackling some harder questions later. That brings us to the end of the video. Thank you so much for watching, and I'll see you next time.